Nobody is talking about the real reason Tesla is building a robot. And once you understand what's actually happening, you're going to look at every single Tesla news story completely differently from this point forward. Let's be honest about something first. When most people hear Tesla robot, they picture Elon Musk showing off a humanoid machine at some flashy event, and then they roll their eyes and move on. Maybe they remember that awkward demo a few years back where two people in robot suits walked out on stage. And sure, the skepticism is understandable. But that framing, the idea that Optimus is a robot project, is exactly the misconception that could make you miss one of the most significant industrial pivots of the last 50 years. Tesla is not building a robot. Tesla is building a physical body for an artificial intelligence system that has already been trained by 4 million vehicles driving billions of miles across every road condition imaginable. That is a fundamentally different thing, and the distinction matters enormously. Here is the fact that almost nobody in mainstream coverage is talking about. The neural network that decides when your Tesla hits the brakes on a highway is the same neural network being used to train Optimus. Same architecture. Same simulator. Same underlying intelligence. When a Tesla in Phoenix navigates a confusing construction zone at 2 in the morning, that data goes into the same system teaching a robot how to handle an unexpected situation in a factory. Tesla's fleet of 4 million vehicles is not just selling transportation. It is the largest real-world artificial intelligence training operation on the planet, and the robot is the next output of that operation. Think about what that actually means in competitive terms. Boston Dynamics has been building robots since the early 1990s. They make extraordinary machines. Their Atlas robot is genuinely impressive. But Boston Dynamics trains its robots in controlled environments, in labs, on obstacle courses, in warehouses where everything is mapped and predictable. They are doing robotics the traditional way. Tesla is doing something categorically different. Tesla's robots are inheriting decades of messy, unpredictable, real-world sensory experience from machines that have already faced rain, fog, aggressive drivers, broken traffic lights, children running into the street, and every other chaotic situation the physical world can produce. The training gap between Tesla and traditional robotics companies is not measured in years. It might be measured in generations. Now, to be fair, this is where the story gets complicated, because Tesla's actual progress on Optimus has been slower and more difficult than Elon Musk's public statements have suggested. In January of 2026, Musk publicly admitted that Optimus robots were not doing useful work inside Tesla factories in any material way. That is a significant admission, given that he had previously claimed somewhere between 1,000 and 2,000 units would be deployed in factories by the end of 2025. That gap between the vision and the reality is real, and any honest analysis of Tesla's robot strategy has to include it. Musk has a documented history of aggressive timeline optimism that does not always match what happens on the factory floor. So when we talk about the bigger picture here, we are talking about a long-term strategic trajectory, not an imminent product launch. But here is why the timeline criticism, while valid, misses the deeper strategic point. Even Musk's critics, who correctly note the delays, tend to evaluate Optimus as a robotics product competing with other robots. And that comparison leads them to look at shipment numbers, where Tesla's approximately 150 units in 2025 look embarrassingly small next to Chinese manufacturer Unitree, which shipped over 10,000 robots in the same period. If you are grading this like a traditional hardware business, Tesla is losing badly. But Tesla is not competing in the traditional robotics hardware market. Tesla is building the infrastructure layer underneath that market, the same way you would not evaluate Amazon Web Services by comparing the number of physical servers it sold versus Dell. Let's talk about what Tesla actually announced in August of 2025, because this is the piece of news that got the least attention relative to how important it was. Tesla shut down the Dojo supercomputer project. Dojo was supposed to be Tesla's proprietary training system, a custom-built supercomputer that Tesla was investing billions of dollars into building. Wall Street analysts had assigned enormous value to Dojo as a standalone infrastructure asset. And then Tesla killed it. The explanation Musk gave was straightforward. Once Tesla's AI6 chip development reached a certain point, it became clear that all computing paths converged to that same chip. building a separate supercomputer architecture was redundant. So they stopped. What that decision reveals is that Tesla is not collecting capabilities. Tesla is converging everything: vehicles, robots, chips, software, energy storage, into a single unified system. The same chip that runs full self-driving is going to run Optimus. The same simulator that teaches Tesla cars to navigate intersections is teaching robots to navigate assembly lines. This is vertical integration taken to an extreme that no other company on Earth is attempting. The financial projections attached to this strategy are numbers that are hard to process without some kind of scale reference. Musk has stated that approximately 80% of Tesla's long-term value will come from Optimus, not from cars. He has projected between $10 and $25 trillion in long-term revenue potential from humanoid robots. A Stifel analyst covering Tesla in 2025 described Optimus and inference as a service as, quote, thesis-defining products that will arguably be worth more than Tesla's other businesses combined. To put the manufacturing ambition in physical terms, Tesla's Gigafactory in Texas, which is already enormous by any standard, roughly the size of 140 football fields under one roof, is being retooled not just to build cars but to eventually produce robots at a target rate of 1 million units per year, with a longer-term goal of 10 million annually, at a target retail price of under $30,000 per unit, and with each unit potentially saving a company $57,000 annually in labor costs. The economic math starts to look less like a product business and more like a platform business with recurring value embedded in every unit sold. This is where the AI platform framing becomes essential. The most useful comparison is not Boston Dynamics. It is not even Figure AI, which reached a valuation of $39 billion in 2025 despite shipping a similar number of units to Tesla. The most useful comparison is what NVIDIA has built with its physical AI ecosystem, including the Jetson computing platform, the Isaac robotics software, and the Omniverse simulation environment. NVIDIA is positioning itself as the operating system of physical artificial intelligence. Every robot company, no matter who builds the hardware, potentially runs on NVIDIA infrastructure. Tesla is attempting something more audacious: to be the hardware, the software, the simulation environment, the training data pipeline, the chip, the manufacturing facility, and eventually the labor force, all inside one company. Whether that level of vertical integration is a genius strategic moat or an overextended liability is a genuinely open question, and smart people disagree strongly on the answer. The critics make real points worth taking seriously. Alan Owensman, a senior editor at Forbes who covers the automotive industry, has described Tesla's robot ambitions as closer to a publicity stunt than a genuine industrial transformation, pointing out that Tesla has no history as a robotics company and that the gap between demonstration and deployment has been enormous. More fundamentally, some analysts argue that robotics businesses are structurally different from software businesses. Software scales at near zero marginal cost. Robots require materials, manufacturing, supply chains, quality control, and maintenance. Scaling from 150 units to 1 million units per year requires solving problems that have no software equivalent. Tesla has never manufactured humanoid robots at scale. Nobody has. The supply chain for this product category does not yet exist in any mature form. These are not small obstacles. And then there is the competitive pressure from China, which deserves more attention than it typically gets in American coverage of this story. Unitree and Agibot, two Chinese robotics companies, combined to ship more than 10,000 humanoid robots in 2025. Chinese manufacturers have structural cost advantages in hardware, access to rare earth materials, and government support that create a competitive environment unlike anything Tesla faced in the early electric vehicle market. When Tesla was building the Model 3, it was competing against established automakers who were slow to adapt. In humanoid robotics, Tesla is competing against nimble, well-funded, government-supported Chinese companies that are already ahead on unit volume. So where does this leave the central question? The title of this video argues that most people are looking at Tesla's robot strategy the wrong way. And the evidence does support that framing, with important caveats. The mainstream media coverage that treats Optimus as a robotics product competing on hardware specs and shipment counts is genuinely missing the strategic depth of what Tesla is attempting to build. The vehicle fleet as AI training infrastructure, the unified neural network architecture, the convergence of chips and software and simulation, the factory automation integration, these elements of the strategy are real, they are documented, and they represent a genuinely different kind of bet than any other company is making. At the same time, the gap between Tesla's vision and its current reality is substantial. The timelines have slipped. The factory deployment numbers have not materialized. The technical challenges are serious. The competitive pressure from China is real and accelerating. Here is the question worth sitting with as you think about all of this. If Tesla's vehicle fleet is genuinely functioning as the world's largest AI training network, and if that trained intelligence can be transferred into a physical robot body at a cost under $30,000, at what point does the labor market calculus change permanently for every industry that employs human beings in repetitive physical tasks? And more personally, do you think Tesla will actually be the company that cracks this at scale, or will it be a Chinese manufacturer you have never heard of, or a startup being funded right now in a garage somewhere? Let us know what you think in the comments, because this conversation is only going to get more urgent as the production numbers start to move. If you do not want to be caught off guard when the robotics story shifts from vision to reality, subscribe to Driven to Distraction and stay ahead of the curve. We cover the decisions, the data, and the dynamics that shape what ends up in your driveway, and increasingly, what ends up working beside you.